Welcome team, a little bit of an introduction to what we're doing in exercise 9.12 today. I'm not going to do all of the questions that you have to do, but I will be doing some of them. Okay, let's take a look at something like number 2b. We've got 5r. Now we know that the column vector of r is this one here, so that's going to be equal to 5, bracket, and then the column vector. And then that's just simply going to be 5 times minus 1, so minus 5, and minus 10. And that would be our column vector form for that. Okay, now let's move on to something like number 3. And I reckon we'll do 3e. I don't know if that's one of the ones that you have to do or not, but we're doing 2p plus 2q, where p is here and q is here. So let's do that. Now, so 2 times p, so 2 times minus 2, 1, plus q, which is, and we need 2 of them, 2 times 6, 2. Okay, now what does that equal to? So when we add this all together, we're going to get minus 4, 2, so that's the first column vector. The second one is going to be 12, 4. Now remember, the top values are x values, so we can just simply add those together. Minus 4 plus 12 is 8, and 2 plus 4 is 6. So that would be our answer to number 3e. Now I'm going to do one more from here, and I might do something like k. This one here, r minus 2p. r minus 2p. Now I know that r is 0 minus 4, so 0 minus 4. And then I'm subtracting 2p, so 2 times p. Now again, p is over here. So 2 times minus 2, 1. And so my next line is going to be 0, maybe I'll give myself a bit more space, is 0 minus 4 minus, and then 2 times minus 2 is minus 4, so minus 4, and then 2 times 1. Okay, now let's do that. 0 minus minus 4 is 4. Minus 4 minus 2 is minus 6. And so that would be our column vector form for that one. Okay, I hope that makes sense to you. Now let's just clear away a little bit of space here. Oops, not quite what I was intending. Grab that over there. Now, which of these column vectors are parallel? So if they're parallel, they will be a multiple of each other. So let's have a look. Okay, I'm looking at this one and this one. If I times this by 3, if I times the first one by 3, I get negative 12, negative 21. Okay, and negative 12, negative 21 is parallel to 12, 21. You might be thinking, how can that be? One's negative, one's positive. Okay, think about this. Here is something. Let's give ourselves some. Let's give ourselves some squares. Okay, think about this. Hey, come back for. Let's view some squares. I don't know what I did then. Okay, now if I drew 1, 1, that's like this, across 1 and up 1. Now I'm going to draw, so I'm going that way, right? Now I'm going to draw minus 1, minus 1. So I start here, I go across 1, down 1. Do you see how those two are parallel? Okay, so they're parallel. So they're parallel. Do we have any others? I'm looking at this one here. I think they're parallel, because if I times this by negative 3, I would get 3, 9. So those two are parallel. So let's just quickly. So we've got this one is parallel to, we said that one. Then we've got this one is parallel to that one. Let's see if there are any more. If you look at this one here, you've got one, the top is half of the bottom. Do we have anything like that? Yeah, we've got one over here. So let's consider those. Why don't we divide both of them by 5? So we get 1 minus 2. And if we divide this one, we could simplify this. Let's divide this by 10. We get minus 1, 2. So is 1 minus 2 the same as, or is it parallel to negative 1, 2? Let's consider. 1 minus 2, we go across 1, then we go down 2. So it's like this. And minus 1, 2 is like this. We go across 1 and then up 2. Is this parallel to this? Well, yes it is. So those two are parallel. Okay, or maybe I'll just click this here. Okay, which means we can say these guys are parallel. So U and U are parallel. Now, this brings us to our last one here. Is 5, 1 parallel to 24? Yes, if we times this one by 4, times it by 4, we get 20 over 4. So that one is parallel to this one here. So I'm happy with that. Okay, what are we going to do from here? I'm not going to do all of these. I will do 9. I think I'll do 9. So with 9, we've got a diagram here. We've got positions A and B. We know the vector. We know they're measured in kilometers. So P is this bit here. Or another way of measuring it, if we went across this way, this is P. And this is the Q, which is the Y change. Okay, so maybe that's more helpful. And we've got to show that P is equal to 20 to 10.9, sorry, to 3 significant figures. So you can see that this is a right angle here because north and east are 90 degrees. So we're just going to go P over 12 equals sine 65. And therefore P is equal to 12 times sine 65. Now what does that equal? Make sure your calculator is set to degrees. 12 times sine 65, what do you know? 10.9 to 3 SF. 3 significant figures. Now we're going to calculate the value of Q. So we could go Q over 12 is equal to, so we've got adjacent and hypotenuse, so cosine 65. And so Q is equal to 12 cosine 65. That gives me 5.07. Okie dokie. Well, I hope that helps that one for you. Let's push that up a little bit. Now, let's have a look at number, I think I'm going to do number 13, which I think may even be one of the ones that you have. So, I'm going to expand. So I'm going to get 5x, 4x, plus 3y, minus 2y, so I'm expanding my column vectors, equals 320. Now let's split it up into two parts. We've got the top lines, 5x plus 3y should be equal to 3. And we've got the bottom line, 4x minus 2y is equal to 20. So we've got a simultaneous equation here. Now I'm going to times both equations. I'm going to times the top one by 2 and the bottom one by 3. And this leads me to, the top one will be 10x plus 6y is equal to 6. The second one will be 12x minus 6y is equal to 60. So those are my two equations. And I'm going to add them together to get 22x, the y's will drop out, equals 66. So x should be equal to 3. And now I can find y by substituting into one of my equations. I'm going to substitute into this one here. 3y is equal to 3 minus 5 times x, I've just rearranged the formula. Now x is, we said, is 3, so 3 take away 5 times 3 is negative 12, so I think y should be equal to negative 4, and that would be how I would do that one. Now we're going to go on to this last one, which may require a little bit more space. I'll just push that down. Okay, we've got this trapezium, and what do we know about it? We've got points. We know that BC is double AD. Okay, well, let's find A to D. How have we gone from A to D? So A is at 4, 5, and plus something gets us to 7, 7. Okay, so our vector is going to be 3, 2. So that's AD. Okay, so that's part A. We've found how do we get from point A to point D? Well, we've gone 3 to get to this 7, and 5 to 7 is 2, so 3, 2. So that is the vector from A to D. Now, the next question is BC. Now, what do we know about BC? We know it's double AD. Well, that means I'm just going to go 2 times AD, and that's giving me 6, 4. And then now I can find the coordinates of C, because going from B to C is 6, 4. So if I start at B, which is 3, 2, and I add the vector, that should get me to C. So 3 plus 6 is 9, 4 plus 2 is 6. So I think that my x value is 9 and my y value is 6 for C. So C is at 9,6. Well, I hope that makes sense, guys. If not, make sure you ask me questions. Really happy to help.